And from HEO to SMD back to HEOMD, we're going to hear about the Human Research Program from Steve Platts. Over to you, Steve.
Thank you. It's a pleasure to be here this afternoon. Also, I'd like to recognize my partner in crime, Lori Abity. She's also online. So when we get to questions, the two of us will be available to answer any. Next slide, please. So here's the Human Research Program mission. So our mission is to enable space exploration beyond low Earth orbit by reducing the risks to human health and performance through a focused program of basic, applied, and operational research. What we'll be talking about today is largely applied and operational research. Basic research is done mostly here on the ground and a little bit on space station. And then all of this leads to the development of human health, performance, and habitability standards, things like radiation exposure limits, CO2 limits, exercise prescriptions, nutritional standards, things like that. We also develop countermeasures and other risk mitigation solutions like compression garments, LBNP potentially for future missions, and pharmaceutical interventions potentially for things like space motion sickness or for bone loss. And then finally, we deliver advanced habitability and medical support technologies, and a number of these technologies are in development right now. Next slide. And so in multiple times in this talk, I'll discuss our phased approach. And we take a phased approach to almost everything. And the phasing can be different depending on what specifically we're talking about. But if we're talking about how we're going to get to the moon and Mars, we're absolutely taking a phased approach. So the first phase for us is the work we do here on Earth. So we have ground-based analogs to look at the various stressors of the spaceflight environment. We have a bed rest facility that we utilize in Cologne, Germany called NVHAB. And there we do bed rest, and that simulates the microgravity aspect of spaceflight. We do isolation in a number of different facilities, Antarctica, NEK, which is in Moscow, and then the Hera, which is at Johnson Space Center, and that's our short duration isolation. And isolation can be used to represent any mission in a smaller vehicle or in a smaller habitat. And then we also have a space radiation laboratory at Brookhaven National Labs, and that's where we do our galactic cosmic radiation simulations. We do a lot of work in low Earth orbit, utilizing the station as an analog for lunar missions or missions to Mars. It's a unique test bed. We have microgravity and a number of different hazards. I'll discuss hazards in just a second. But you know, it's a great base for us to get a lot of information. And then finally, the lunar missions. Decreasing Earth dependence around and on the lunar surface, that is going to go a long way to helping us for Mars missions. It'll provide insight into deep space radiation, something that we can't simulate really in a human here on Earth or even in low Earth orbit. Behavioral health, the further away from Earth you get, the more stress that the individual sees. And then those gravity transitions, we haven't been able to replicate the gravity transitions since Apollo. So it's unique. It's going to be incredibly important for our long-term missions. Next slide. And so I mentioned hazards. So, you know, we are part of NASA, so we have to give an acronym to everything. So we've identified 5 hazards to the human in spaceflight. And so we call it RIDGE. So the R stands for radiation. I is for isolation and confinement. D is distance from Earth. G is gravitational fields or the lack thereof. And E is environments. And you can see where each one of these poses a unique stressor to the human body. But spaceflight gives us all of these put together, and much of the research that's been done in the past is done on 1 or maybe 2 of these hazards. Very, very little has been done on the entire holistic group of hazards that the human sees. And being able to do research on the station, being able to do research on Artemis and on the lunar surface is really going to help us to make Mars a success. Next slide. And as we work here on Earth, this chart really just shows that if you look at research opportunities here on Earth, we have lots of different facilities. We have essentially unlimited human capital that we can tap into, large laboratories, all the equipment we could need. Um, but if we look at mission constraints, we don't have any, but we also don't have a realistic spaceflight environment. And as we progress through low Earth orbit, through Lunar, and to Mars, you can see that we have a change in the research opportunity. So we have less time available to do research, fewer resources, and mission constraints go up. Again, time, resources, and we have to be able to maximize that. So the research that we're proposing for the future takes all of that into account and tries to maximize as much as we can. Next slide. So why do human research on Artemis? To us, it's a no-brainer, but it might not be obvious that this mission represents a truly unique opportunity to gather data to characterize the effects of deep space and operational environments on astronauts. And we haven't had that since Apollo. And even on Apollo, that was relatively limited. So the opportunity to study the radiation and the microgravity transition to lunar gravity, and then transition back to microgravity, and then transition back to 1G. How is that going to affect the human body? Right? We can postulate all we want. The answer is we really don't know what that's going to look like. This unprecedented mission will have both females and males living and working together. Again, we have opportunity to see that on the space station, but we have not had that opportunity in other venues. And the opportunity to study females has been quite a bit limited. So we're looking forward to having a more equal distribution of men and women participating in these missions. And then finally, I mean, the scenario to understand how the human adapts to all of those hazards that I mentioned of spaceflight, and then maintain a high level of mission performance in a very constrained environment, right? That's a lot to do. And so again, these missions are going to make this possible, and it's something that we just can't do anywhere else. We can't do it here on Earth. We can't do some of it even on station. Not until we get to the lunar environment are we really going to be able to study a lot of these things and how they interact with each other. Next slide. And so our mission philosophy for Artemis, and this first bullet I think is the most important, and these first few words in red are the most important. Unobtrusively and non-invasively. We're going to quantify all of the training, the risk management, the workload, the countermeasures, all of that together to try and understand how all of these lead to a successful mission. We will be proposing low mass, low volume, things like wearables, other technologies that will allow us to look at as much as we can in the human system um, without having a big impact on time. We will have an in-depth characterization of the individuals. And this is a mind shift that has gone on in the last, I don't know, 5 or 10 years on how medicine is practiced. And so, we're not just talking about medicine of populations, we're talking about medicine of individuals. And this has not been available, and it's newly coming into practice. And we can develop countermeasures for individuals. We can look at the metadata for specific vehicles, and we have a lot more information and a different way of looking at it. Computing power has progressed so much even in the last few years, that we can do analyses almost real time that used to take us days or weeks to do. And finally, it's important to mention this applied research approach that we're taking. And we are quite an applied research program, but we're very risk focused. What are the major risks we need to deal with? What are the things in the human that are most important? Where are the weaknesses? Where are the strengths? How are we going to maximize this human system in a mission? And the Artemis missions will enable this Moon to Mars benefit uh, for the sustainable lunar campaign. Next slide, please. And so our goal is to advance the knowledge to support safe, productive human space travel and perform systems testing to reduce risks for future human exploration. Again, our applied approach, we are looking at a very risk-based focus. And then we have 5 objectives. The first, exploration medical operations advancement to evaluate and validate Earth-independent crew health and performance systems in operation. This is very important for that moon to Mars aspect of it. When we have a 20+ minute comm delay and we're going to have a significant autonomy, we need to test that. We need to figure that out well beforehand, and that's part of our objectives. The integrated human system research, I've mentioned this a few times. Um, Evaluate the changes to the human system and validate countermeasures, right? So we have countermeasures that we validated for shuttle and for low Earth orbit. Are those still going to apply on the lunar surface? We can, again, hypothesize that they will, but the answer is we really won't know until we look at them. The living environment. So a lot of people don't realize how living your environment really is. Evaluate the interactions of the habitation system and all of the spaceflight hazards and validate crew health and performance. And so the microbiome is something that we've talked about quite a bit as scientists, and lots of people realize that the microbiome is inside our gut, right? And so we eat yogurt and we have all of these other drinks and pills and everything to sustain our microbiome. But our microbiome extends well beyond that, right? It's on the surface of our skin, it's in our hair, it's on our eyes, and it's on our environment. It's the walls of the station, the walls of any of our vehicles will have living organisms, and we need to evaluate that as much as anything else. Special task related issues. So evaluate and validate operational implementation of critical tasks and human factors for adequate crew health and performance. And then finally, extended mission durations. For us, again, this is our moon to Mars. Test crew health and performance with the hazard environments, mission durations, and systems representative of Mars class missions. This has been on our radar for a long time, and it's one of our main focus points is to get that level of fidelity so that we can really look at what we think is going to happen on a Mars mission. Next slide. And this sort of represents that the vision and again how we have kind of parsed out the work. So the early human research payloads have been identified. In fact, we already have the task synopses for the actual experiments that we hope to do for Artemis 2 into our internal merit review process. So we're well on our way for that. As we move to later missions, so we have the next will be mainly self-reliant, but moving towards Earth independence, where we have some in situ analysis, but limited sample return. We'll add more studies. The hybrid Earth reliant, Earth independent is where the in situ analysis capabilities become more on board. Again, that'll be really critical for us to identify as we move forward. Fully Earth independent and then shakedown is when we're pushing that moon to Mars aspect of it. Next slide. And so here are the 9 payloads that we've identified for early Artemis. Ultrasound, and this one will be critical for us. Many of our most important risks can be evaluated using ultrasound. So even though it's one payload, it's actually many potential experiments and very critical. The newer machines are handheld machines. Crew and team performance measures, these are largely surveys and things like that. Spaceflight standard measures, which will be a subset, a lot of pre and post flight, and then potentially some in-flight work as well. Dry saliva sampling booklets. So these are dry little booklets where you just wet it in your mouth, and then you'd be shocked at how many analytes and how many biomarkers we can look at that relate to stress and other markers in the human just from that. The crew health data management system, a heart rate monitor, again, something like this wearable. Lunar ascent, descent, dynamic loads, injury assessment, again, a survey, computer type work. alterations of multisensory integration due to combined hazards, and then finally blood analysis. And what we're looking at right now is dried blood spot analysis. Next slide. And so to conclude, the Human Research Program is dedicated to discovering methods and technologies to support safe, productive human spaceflight. And by conducting human research on early lunar surface crews, we hope these results will help inform missions of tomorrow, most notably missions to Mars. So thank you.
Thank you very much, and looking forward to the question period to follow up.